Here we have a problem on logarithm. Okay, let's go to the question. If log x to the base 2 positive log x to the base 4 positive log x to the base 16 equals to 7 over 2, find the value of x. Okay, in this equation we have to solve for x. Okay, first let me write the given equation as it is. It is log x to the base 2 positive log x to the base 4 positive log x to the base 16 equals to 7 over 2. Okay, here if I want to add logarithms using the product rule of logarithm, what I need is I need the same base for all the logarithms. But here the base of the first logarithm is 2, base of the second logarithm is 4, and base of the third logarithm is 16. Since the bases are different, I cannot use the power rule of logarithm to simplify the logarithmic expression we have on the left side. So for that, what I'm going to do is I assume there is 1 multiplied by the first logarithm. That is, we can assume there is a coefficient of the logarithm over here is 1. So that is 1 multiplied by this logarithm, and coefficient of this logarithm is also 1. That is, there is 1 multiplied over here, and there is 1 multiplied over here. Okay, now I'm going to move this log x to the base 2 to denominator. Whenever I move a logarithm from numerator to denominator or denominator to numerator, I have to switch the base and the argument. So that is the argument over here will become the base, and the base 2 will become the argument. So now I move this logarithm to denominator. When I move it, it will become log 2 to the base x. So the argument x becomes the base of the logarithm, and the base 2 becomes the argument. So the same process we have to do for this one. In that case, I'm getting 1 over log 4 to the base x, and here I'm getting 1 over log 16 to the base x equals to 7 over 2. So here you may have a question, why do I do such a thing over here? Because I need the same base for all the logarithms. So for that purpose only, I just moved each logarithm to the denominator. Okay, now let me write the first one as it is. That is 1 over log 2 to the base x positive 1 over in the second logarithm. So actually 4 is a power of 2. So 4 can be written as 2 square. Let me do it. So 2 square positive 1 over a log 16 is also a power of 2. It can be written as 2 to the 4th power equals to 7 over 2. Okay, 1 over log 2 to the base x positive 1 over here. I can use a power rule of logarithm. That is, whenever the argument is a power, so the exponent over here can be moved in front of the logarithm, and it has to be multiplied by the logarithm. Then I'm getting 2 times log 2 to the base x positive. So the same power rule can be moved, can be used over here. That is, the exponent of 4 that we have in the argument can be moved in front of the logarithm. Then I'm getting 4 times log 2 to the base x equals to 7 over 2. Okay, let me continue the stuff over here. Okay, when I consider the three fractions I have over here, so the denominators are different, and each denominator contains a log 2 to the base x, but the coefficient of the logarithm is not same. So here in the first denominator, the coefficient of this logarithm is just 1. In the second one also we have the same logarithm, that is log 2 to the base x, but the coefficient is 2. So here the coefficient is 4. Okay, so whenever I want to add 2 or more fractions, I need the same denominator. So to add these three fractions over here, I need the same denominator. For that, I have to get the same coefficient for the logarithms we have in denominator. So let me consider the coefficients 1, 2, and 4. What is the least common multiple of this 1, 2, and 4? That is 4. That is, we have to get the coefficient of each logarithm in denominator as 4. For that, we have to multiply the numerator and denominator of the first fraction by 4. Okay, let me do it. Okay, here in the second fraction, I have to multiply both numerator and denominator by 2. So that 2 times 2 will become 4 as a coefficient of this log 2 to the base x. And I have nothing to do with the third fraction because already we have 4 as a coefficient for the logarithm, that is log 2 to the base x. Okay, now when I multiply this 4 and 1, I am getting 4 in denominator. I am getting 4 log 2 to the base x. So in the second fraction, 2 times 1 is 2 divided by 2 times 2 is 4 times log 2 to the base x positive 1 over 4 times log 2 to the base x. I am writing the third fraction as it is equals to 7 over 2. Okay, now for all the three fractions over here, we have the same denominator, that is 4 times log 2 to the base x. Now we can take this 4 times log 2 to the base x as a common denominator, and we can add the numerators of 4, 2, and 1. So let me add them. There is 4 positive, 2 positive, 1, and we can take 4 times log 2 to the base x as a common denominator equals to 7 over 2. When I add 4, 2, and 1 in numerator, I'm getting 7 over 4 times log 2 to the base x equals to 7 over 2. Okay, now what I can do is I can move this logarithm to numerator. As I said already, when I move the logarithm from denominator to numerator, so I have to switch the base and argument. Then I'm getting 7 times log x to the base 2 divided by 4. So since I moved this logarithm to numerator, this argument 2 becomes a base, and this base x becomes a argument, equals to 7 over 2. Now, to get rid of the 7 in numerator over here and 4 in denominator over here, I'm going to multiply both sides of this equation by the reciprocal of this fraction, that is 4 over 7. Let me multiply both sides by 4 over 7. So here this 7 will cancel out, and 4 will cancel out. 2 goes into 2 one times, and 2 goes into 4 two times. 7 goes into 7 one times, and here 7 goes into 7 one times. Okay, let me continue over here. The resulting equation is log x to the base 2. This is the stuff we have on the left side. On the right side, we have 1 times 2 divided by 1 times 1. That is 2 divided by 1 equals to 2. Okay, now to solve for x in this equation, what I have to do is I have to convert this equation to exponential form. Already this equation is in logarithmic form. Okay, so to convert this equation to exponential form, what I have to do is I have to consider the stuff which contains logarithm. So here the stuff on the left side of this equation contains logarithm. So in this particularly I have to consider the logarithm along with its base, that is log to the base 2. Now to convert this equation to exponential form, I have to move this logarithm with base 2 to the right side of the equation. When I move this logarithm with base 2 to the right side of the equation, I have to ignore this logarithm. I have to consider only the base 2 on the right side of the equation. The value which already exists on the right side of the equation will become the exponent of this base. On the left side, we just have x. Okay, now x equals to, the value of 2 square is 4. In the given equation, I got the value of x. The value of x is 4.